A truck with a 44-inch diameter wheel is traveling at 50 miles per hour. A. Find the angular velocity in radians per minute, and B. How many revolutions per minute do the wheels make? The first thing to recognize here is if the diameter is 44 inches, then the radius r is 22 inches, which is half of the diameter. And now looking at the formulas below, the linear velocity v equals the radius r times the angular velocity omega. And because we are looking for the angular velocity, we divide both sides by r to solve for omega, which gives us omega, the angular velocity, is equal to v, the linear velocity, divided by the radius. Before we use this formula to answer part A, though, let's better understand why the linear velocity v is equal to the radius r times the angular velocity. Remember, when the central angle of a circle has a measure of 1 radian, then the intercepted arc, this arc here, has a length of 1 radius, which means when the wheel rotates 1 radian, the linear distance traveled is equal to this arc length, which is equal to 1 radius, which is why to find the linear velocity, we find the product of the radius and the angular velocity. As an example, if the angular velocity is 8 radians per minute, again, each radian of rotation, the wheel would travel a linear distance of 1 radius, and therefore if the radius is 10 inches, the linear velocity is equal to 10 times 8, or 80 inches per minute. So now going back to our example, we are given the linear velocity of 50 miles per hour, but before we find the angular velocity, we will have to convert 50 miles per hour into inches per minute. So beginning with the given velocity of 50 miles per 1 hour, let's begin by converting miles to inches, and then we'll convert hours to minutes. We'll perform the conversion using unit fractions. And because there are 5,280 feet in 1 mile, and we want miles to simplify out, we'll begin by multiplying by the unit fraction of 5,280 feet divided by 1 mile. The units of miles simplify out. And now let's convert feet to inches. Because there are 12 inches in 1 foot, we want feet to simplify out. We multiply by the unit fraction of 12 inches divided by 1 foot. And again, notice how feet simplifies out. And now let's convert hours to minutes. There are 16 minutes in 1 hour. We want hours to simplify out, and therefore we multiply by the unit fraction of 1 hour divided by 60 minutes. And the hours simplify out. And now multiplying, in the numerator we have 50 times 5,280 times 12 inches divided by, in the denominator we have 60 minutes. And now simplifying, 50 times 5,280 times 12 divided by 60 is equal to 52,800, and we now know the linear velocity v is equal to 52,800, and the units are now inches per minute. So now using our formula, we know the angular velocity is equal to the linear velocity v divided by the radius, and this quotient gives us 52,800 divided by the radius of 22 inches, and this quotient is equal to 2,400, and therefore the angular velocity is 2,400 radians per minute. And now for part B, we need to determine how many revolutions per minute the wheels make. Well, the revolutions per minute is equal to the angular velocity divided by 2 pi, because remember, 2 pi radians is equal to 1 rotation, or 1 revolution. So the revolutions per minute are equal to the angular velocity omega divided by 2 pi radians. And we know the angular velocity is equal to 2,400 radians per minute, and therefore the revolutions per minute are equal to 2,400 divided by 2 pi, which is equal to 1,200 divided by pi. And of course, units here are going to be revolutions per minute. So this would be the exact revolutions per minute. Let's also get a decimal approximation. We have 1,200 divided by pi, which gives us approximately 381.9719 revolutions per minute. So we have the exact RPMs and the approximate RPMs. I hope you found this helpful.